Hello, my name is Trey Tyler. I am a member of the technical staff here at VMware, a part of the Cloud Management Business Unit for vRealize Network Insight. For today's video, we will be doing an overview of the Network Insight product. To begin, I would like to go over the architecture of Network Insight. vRealize Network Insight is comprised of two primary components. We have our platform component and our proxy or collector component. The platform will serve up your user interface as well as process all of the information that has been collected by the proxy. The proxy will communicate with all of your data sources that are seen on the screen, collect information, and send it back to the platform for processing. The proxy will also listen for IPFix, NetFlow, or SFlow communications from data sources as well. This flow-related information can be used to analyze traffic patterns, define applications, or plan for microsegmentation with NSX. For more information regarding the deployment of Network Insight or requirements for supported data sources, please see the documentation on docs.vmware.com. Jumping back to the Network Insight user interface, I'd like to show you how to add data sources. To do this, go to the top right corner gear icon and select Settings. In this demo environment, you can see I have a lot of data sources that have already been added. From this page, I would be able to enable, disable, or edit those existing data sources. To start adding a new data source, you will need to navigate to the top right corner and select Add Source. Then select the type of data source you would like to add to the environment. We'll start with vCenter. After selecting the data source, you'll simply choose the collector virtual machine that's deployed you want to collect on this data source. Enter in the IP address or FQDN information as well as a username and password. Then by selecting Validate, we will verify the credentials and information you have provided in the above fields. After successful validation, you will be able to submit and save the data source. For some data source types, such as vCenter and NSX Manager, there will be additional options you can select after you validate the data source. In the case of our vCenter environment, we have the ability to enable NetFlow or IPFix on the vCenter's VDS. And finally, before submitting, you are able to give a nickname to the selected data source. Coming back to our Accounts and Data Source page, if I select Add Data Source, you can see that there's a lot more than just vCenter and NSX Manager to add as data sources. Coming further down, we can see there's various public clouds, containers, firewalls, routers, switches, load balancers, and many others. You can even convert an existing proxy to collect on NetFlow or SFlow from your physical devices. By enabling vCenter or NSX IPFix and physical NetFlow, this will allow you to see flows from virtual machines to virtual machines to physical devices, as well as physical devices to other physical devices. After the addition of data sources, it's advisable to set up your event notifications. Event notifications consist of system events or out-of-the-box alerts pre-configured by Network Insight, user-defined events or events that are created by users using Network Insight, or platform health events, which are events directly related to the health and functionality of Network Insight. For our initial configuration, let's focus on system events. In vRealize Network Insight version 5.3, there are 281 different pre-configured system events. All of these are enabled, but as you can see, none of them have been configured for notifications. To start with our event notifications, I'd like to focus on the NSX-related events. We'll do this by typing NSX in the search bar. As you can see, we have narrowed down our search results to 151 specific events. To further filter this, we can change our severity to look at only the critical events out of these 151. This brings us down to a total of 51 events for configuration. These can either be configured individually by selecting the Edit pencil on the right-hand side, or we can select multiple or all of these events with the radio button on the left. With multiple selections chosen, we can then enable, disable, or edit these in bulk. From here, simply configure any event tags that you would like added, change the event severity, choose what sort of email frequency you would like for alert notifications, select the email for notifications to be sent to, or choose the SNMP trap destination for notifications to be sent to. From here, simply submit your changes to complete configuration. After configuring system-related events, it's advisable to configure platform health events to monitor the health of Network Insight. Just like our system events, platform health events will be configured in the same manner. Events can be configured individually or in bulk, and notifications can be sent either through email or SNMP traps. And lastly, we'll take a look at user-defined events. On this page, you'll be able to see all of the events that a user has defined. Since these are not out-of-the-box events, you will need to configure these and create them on your own. This will be done by searching for specific criteria you would like to alert on. We'll look for flows where a specific traffic rate is exceeding 2 gigabits per second. As you can see, there are no results for the specific search. And because of this, we can create an alert by clicking on the icon indicated here. From there, you will need to simply populate the fields in the provided pop-up. To trigger these alerts, we can either choose when results change or when there are 0 results for our search. In the case of this alert, we will leave it for when the search results change. Lastly, choose where to send notifications, either through email or SNMP trap destinations. Then commit the configuration by selecting Save. With Network Insight now collecting on all of our data sources and alerting and events currently configured, it's time to take a look and see what type of searching capabilities we have to look at the data we've collected. Starting with the most basic search, we'll put in an object name in our search bar and click Search. Here we're looking at flows. As you can see, when just searching for an individual object ID, what we get in return is a list of all of those specific objects. Here we have 45,225 individual flow objects in Network Insight. From here, some object types will have a plus symbol allowing you to expand the details of each item in the list. Additionally, some objects will default search with a certain metric on it. Here you can see the total flow traffic and the network rate. By mousing over this diagram, I can see the specific rate at any point in time along with the date and the timestamp of that metric. Now, while this is great to look at all of this information, 45,000 plus individual results is probably going to be too difficult to look at and showing you too much information at once. That's why we'll add filters onto our existing search to go ahead and narrow down what we're looking at. Filters can be added on the widget on the left-hand side by choosing the specific filter you're looking for. Or, in our case, we'll go ahead and add a filter into the search bar itself. We'll do this by typing the word where after the object and then the filter type that we're looking for. In this case, we'll choose flow type where source is internet. Now we've narrowed down those 45,000 results down to around 13,000. If this still isn't specific enough, you can always add additional filters by using the AND clause for your search query. Now we'll add an additional flow type where the destination is equal to a virtual machine. With the addition of this new search filter, you can see that our search results has been reduced yet again. In certain cases, you may not want to continue to reduce your search results, but rather broaden your search results into 2 different sets of criteria. In this case, what we can do is modify the search results to use an OR statement instead of our AND statement. Now what we'll do is add a different flow type to show all of the flows that are coming from the internet or going to the internet by adding flow type equals destination is internet. In this case now we've gone from roughly 13,000 individual results to now 24,000 results. The next thing we want to do is, instead of looking at all of these results as a list view, is put them into a table. This makes it much easier to go ahead and interpret large amounts of data all at once. So let's go ahead and remove the additional search criteria after our flow object, and then we'll search by using the group by method. In this case, I want to look at all east-west traffic. So we'll group all of our flows by the source layer 2 network, add a comma, and also group by our destination layer 2 network. What this should give me is a table of all communications between each and every individual layer 2 source and layer 2 destination network. As you can see, we're looking at about 45,000 flows, but we've grouped them into 162 individual rows. For the columns of this table, we'll have our source networks, destination networks, and the individual flow sets for that pair. To take this a bit further, we'll add a metric to resort all of these source and destination pairs. In this case, we'll look at the sum of total bytes of the pairs. Now you can see that we have a new column within our table that's showing you the amount of traffic that has been sent within the last 24-hour period from any given source or destination layer 2 network. The last thing we can do to expand on this existing search is to add a metric to visualize the flows between this source and destination pair. We'll do this by adding a series modifier. Here we're looking at the series, the sum of the bytes rate of all of the flows for any given source and destination layer 2 network. What the series modifier is doing is taking the aggregate of all of our flows for any given source and destination pair and providing an individual metric that's showing you the total traffic rate for all of those flows in a single metric diagram. As you'll notice, the spikes or peaks of any given metric on these types of diagram will be highlighted in a darker color than lower values of the metrics. Something else you may be interested in doing from a searching perspective is looking at multiple metrics at one time for any given object. What we'll do next is list a bunch of individual metrics for a virtual machine and look at all of those metrics together for each virtual machine in our search results list. To do this, we'll simply type out each virtual machine metric we're interested in and separate them with commas. We'll look at things like CPU usage rate, memory usage rate, network send rate, network receive rate, and total drops. After listing all of the metrics for the object that you're interested in, we'll simply type of and then the object in question. As you can now see, we have a list of all of the virtual machines with the given metrics that we've requested. We can then filter these results just like we did with our flows by adding a like clause. In this case, we're going to look at all virtual machines where the virtual machine name is like iPerf. Now let's say I want to look at a related object to all of the virtual machines where the name is like iPerf. What I can do here is close bracket my VM like iPerf clause and add the new object I'm interested in. In this case, we'll look at all of the VMware hosts where the virtual machine is like iPerf. In this case, we'll get all of the metrics that we were looking at previously, but now in relation to the host that supports the virtual machine rather than the virtual machine itself. As you're going through and building all of these very complex and unique searches, it might be wise to go ahead and save these searches. You can do this by navigating to the right-hand side of the search bar and clicking on the bookmark icon. You can then recall any of these saved searches using the bottom left-hand bookmark icon for saved searches. Now, as we've been going through and performing all of these different searches, you may have noticed the pin icon in the very top right of our search results widget. By clicking this, it will allow us to add any of our search results to a custom pinboard, almost like a dashboard of custom information. To make this pinboard more interesting, let's flip through some of the old searches we've done just recently and pin them to this test pinboard. With at least 2 pins now on our new pinboard, we can go ahead and take a look at the pinboard itself. Now that we have 2 different search widgets on this pinboard, let's see what we can do to modify this. Firstly, you can go ahead and change the names of the widgets that you've created to something that's more friendly for anybody that's looking at the dashboard. If you'd like, you can maximize any individual widget to get a better view on the data that's inside the widget. Of course, the reverse is also possible as well. These widgets may also be minimized. In a situation where you have many widgets on a single pinboard, you can click on the center of the title bar of each widget to reorganize the way that the widgets are displayed on the pinboard. To more easily determine the purpose of the pinboard, you can go ahead and label the entire pinboard with a specific title. After making any significant modifications to your pinboard, make sure to save those changes. Something else you'll notice when looking at the widgets on your pinboard is the date and time for each individual widget. There will either be a specific time or a time range. You can modify the time displayed on each of the widgets by navigating to the time bar on the pinboard and selecting a different time range, or a specific point in time. By selecting a new time on this time bar, you can see that the widgets will now update with the new specific time. Here we're now seeing August 4th as opposed to August 10th previously. When you're satisfied with your completed pinboard, you may want to share it with other users. You can do this by clicking the share arrow up top. With the sharing options open, you can see that you can copy a link to provide to a new user, or you can invite the user directly in the tool itself. Users can be invited to view and edit, or view only for your pinboard. If you would like to share information with a user that does not have access to Network Insight, you can always export your pinboard to PDF. In addition to this option, you can see that you may also duplicate the pinboard for further editing. You can delete the pinboard entirely. You can set this pinboard as your default home page when you log into Network Insight, or we can switch the pinboard to the original pin time. This will refresh each widget within the pinboard to the time in which it was originally pinned to the pinboard. This is particularly useful when sharing information for troubleshooting purposes. With pinboards out of the way, let's talk about defining applications within Network Insight. An application in this case would be defined by a group of virtual machines all working together to provide a single service. We'll use a predefined application I have called Top Video as our primary example. This is the application's dashboard page. The application dashboard will give us a high-level overview and summary of flows and various metrics related to virtual machines of the application. On the application topology page, you can see individual groups or tiers of virtual machines that make up the application. On each of these icons, if there are issues related to the virtual machines within that tier, you will see a red icon indicating the number of problems within that application tier. The white lines connecting each of the application tiers to other icons indicate that there is flows or communications between those two tiers. Any of the icons or lines that you see on this diagram are clickable. If you click on any of these icons or lines, it would bring up a window showing you more information regarding the application tier, the virtual machines within the application, the physical infrastructure that supports the application, or individual sets of flows between tiers. Scrolling further down in this application dashboard, we can see related events for the virtual machines within the application. We can also see the application members manager, or vCenters or NSX managers that manage the virtual machines that make up the application. Coming further down and expanding the other sections, we have a What's New section that gives you an idea on the traffic patterns, new access services, or new access ports within the last 24 hours. Below that, we have a metrics section, which will give you network information regarding the virtual machines or the Kubernetes metrics related to the application. Next, we have a section showing you all of the flows and flow metrics related to the virtual machines in the application. And lastly, we have a microsegmentation area. This we'll save for a later part of this video. As you can tell, there's a lot of good information within a defined application, but you may be wondering, how do I create one of these? There are several different methods of creating applications. This can be done by manually adding an application by clicking Add Application. From there, you would define the application name, and then enter in the names and virtual machine members of each application tier that makes up this application. There are various values you can enter in as a tier member. This consists of virtual machines, individual IP addresses, or Kubernetes-related services. The most common way of adding members manually is going to be by explicitly naming virtual machine names, as you can see here. Or we can define a custom virtual machine search. This allows the application tier to act dynamically by matching virtual machines that meet a specific search criteria. If applications evolve over time and new virtual machines match the search criteria of the application tier, those members will automatically become a part of this defined application. Once you've completed defining your tiers, simply select Save to save the application. While manually creating applications is effective and works, discovering applications might be more feasible if you have thousands and thousands of virtual machines making up hundreds to thousands of applications. Because of this, we've introduced several other ways of discovering multiple applications at a single time. This can be done either through vCenter tags, ServiceNow integration, analyzing collected flows, existing virtual machine names, and an advanced method which uses names, tags, and other various methods all together. Let's start off by looking at the tags discovery method. The first thing you'll notice is that we can limit the scope of virtual machines that we're looking at for discovery, from all virtual machines to a manual selection. The manual selection will use a virtual machine search to narrow down the virtual machines that you'll be looking at when discovering applications. From here we have two grouping options, grouping by applications, then grouping by tiers. What we need to do from here is put in the vCenter tag that would be the grouping by applications, and you can see on the bottom right the number of applications that are found that match that tag. By clicking on this, we can get an idea of what the matches are as well. Next, we'll update the group by for tiers, and we can see the individual tiers that are found. Here we have 13. We can see the tier name, the application it's associated with, and an idea of the virtual machine names on the right. The method for ServiceNow is even simpler. Simply by adding ServiceNow as a data source, application and tier level CIs, and display the applications discovered here on the right-hand side. Once discovery is done, simply click Save to commit any changes for individual applications. Virtual machines based off of their names is simple as well. Of course, we have our scope option, like we saw on tags earlier. Then using regular expressions, we can filter virtual machines by applications as well as grouping by tiers. Regular expressions is something you're not familiar with. We have a pattern builder which will help build regular expressions for you. Simply type in the naming convention of your virtual machines and select on individual positions or groups of the virtual machine names to build the regular expression. Not only will we display the actual expression that is being used, but we'll also display a preview of the results that match this regular expression. From here, you would simply click Submit to see all matches. Moving on and taking a look at the advanced method, most everything that you can see here is familiar and comparable to tags and names. The primary difference is that we can now use names, security tags, security groups, and vCenter tags combined to define applications. If none of these features work for you, the flow-based application discovery may be the best method for you. The flow-based application discovery feature will use flows collected by vRealize Network Insight and defined applications by the virtual machine traffic patterns. When initially starting to use the flow-based application discovery feature, you will find a button that just says Discover Applications. In our case, we've already discovered the initial application set, so what I will need to do is modify my scope to look at flows for a specific area of my environment. This will allow me to focus on a set of flows for application discovery. The scope can be limited to various different entities such as data centers, clusters, vCenters, specific networks, and several others. Once the scope has been decided on, vRealize Network Insight will process the flow information to decide on application recommendations for you. The output of these recommendations will look like something you see here. Defined applications can be seen on the right-hand side. You can see we have 93 individual applications that have been discovered on the flow set we analyzed. One of the primary things you can do to control the output of the application recommendations is by changing the granularity. Here I've changed the granularity from medium to coarse, and you can see that the applications drop down to 82. If I adjust this up to a fine granularity, the number of applications should increase to 106. By adjusting the granularity, what you're doing is changing how strict vRealize Network Insight is being with its grouping of virtual machines by related flows. By going with a fine granularity, you are being very strict and assuming that all virtual machines are very much like one another. By going to a coarse granularity, we're allowing for specific virtual machines to have outlier flows when compared to other machines within the tiers. The application's name will be based on the virtual machines that make up the recommended application. Network Insight will also provide a confidence level in the accuracy of the recommended application. While flow-based app discovery will discover applications, it will not automatically save them. It is up to you to commit changes on any sort of applications that have been discovered. These, of course, can be edited before saving. Application names may be modified to something more friendly. The same goes for application tiers. You may also modify the members of each tier within the application before submitting. Moving away from applications, let's talk about the analytics portion of vRealize Network Insight. There are three primary analytics that we can use: outliers, thresholds, or flow insights. First, we're going to look at flow insights. What flow insights will do is take any set of flows, in this case we'll look at all flows for the past day, and it will analyze and give you a breakdown of your top consumers of those flows. What you now see on screen are the top talkers for all flows within my environment in the past 24 hours. Here I can see the top consumer by flow volume is iPerf to iPerf1. Our top consumer by traffic rate is also the iPerf client 2 to iPerf server 1. We also have session count and flow count as metrics for the top talker widget. In addition to viewing the source and destination pair for flows, there are different ways of filtering these top consumers. The dropdown will allow you to choose which object you would like to look at. In this case, we'll look at the top consumers of all flows by virtual machine. While the output looks similar, you can see now that I'm only looking at individual virtual machine metrics instead of source and destination flow pairs. Coming further down to the What's New section, this will show us new flow information within the past 24 hours for my flow search. We can look at new virtual machines accessing the internet, new east-west services being accessed within the environment, or new blocked flows within the past 24 hours. For network performance, we'll be specifically looking at the round-trip time of a specific set of flows. This information is provided by the NSXT infrastructure latency metrics. What this diagram is going to be calling out is flows that have deviated from their average by a certain percentage or by an absolute deviation. For any flows that have exceeded these thresholds, they will be called out as abnormal or troubled flows. For the last portion of the flow insights, we'll look at outliers. Outliers will be broken down into elephant flows or custom analysis. To use the custom analysis, simply choose a specific outlier object, whether that be a virtual machine, cluster, data center, or set of flows, and then choose your X and Y axis to analyze the data on. You can see here that we have source bytes and destination bytes as our XY axis for this chart. From here, simply mouse over any points on the chart to see information regarding what virtual machines or object is being called out. Here we can see iPerf server 2 and iPerf server 1 are the two top prime consumers of source byte traffic. Moving on from flow insights, let's take a look at threshold analytics next. We'll start off here by adding a new threshold configuration. Before beginning anything, you must give this threshold a name. First, we'll start out by looking at a set of flows. I'll look at flows where the flow type is equal to source is the internet. This will find roughly 25,000 individual flow results. Since there are so many individual flows, what we want to do is aggregate this set of flows over the entire scope. This will create a single chart for all 25,000 flows to give us an indication on the network traffic rate of these flows combined. If you'd like, you can always change the metric that we're looking at to a different metric that you can see here. If you'd like to look at something like session count or packet count instead of total traffic rate, this is totally fine. Our next step is to create a threshold value for our alert notifications. These can be set on any value or based off of an average. The threshold can be set on a exceeds threshold, drops below threshold, a set range, all of which can be configured over here on the left-hand side. Or if we choose deviates from previous behavior, we would choose a sensitivity. This option will use a standard deviation algorithm to notify you when traffic is behaving differently than it has previously in the past. Aside from looking at individual flows, we can look at metrics on virtual machine sets as well. Simply perform a search like we had previously. This time we'll look at virtual machines that are a part of the application top video. Now in this case, we only have 24 individual entities. Since the entity count is lower, we can look at all of these entities at the same time on a single chart. You can mouse over the individual metric to highlight the virtual machine name, or we can highlight the entities on the right to show their respective metrics on the left. You'll notice as well that the metrics for virtual machines are different than the metrics for flows. Here in this case, we've introduced packet loss as a metric for virtual machines. If you're less interested on individual virtual machine metrics and you would rather look at the entire scope of the application, again, you can change that here. And finally, before saving this threshold configuration, we can configure notifications. Here we can set our severity, email frequency, the email notifications on where those should be sent, as well as an SNMP trap destination here. And for our last analytics feature, we'll move to outliers. Like before with thresholds, we'll select Add to create a new outlier configuration. Then provide this a name. Unlike the threshold configuration, the scope of an outlier must be related to an application tier or a security group. We rely on the likeness of virtual machines within the group in order to compare them against one another. The outlier configuration we're making now will look at all the virtual machines within the web tier of the FitBike application. Here we'll select the port 80, which is the primary listening port of all of these virtual machines, and then we will display the web traffic on each of those virtual machines on a single chart. Scrolling down, you can see we can change things like the individual ports that we're going to be listening on. We'll start with port 80. From here, we can analyze specific metrics for the flows. Here we're looking at all flow traffic. We can choose a traffic direction. We can also choose a traffic type or protocol. And lastly, we can choose the sensitivity for our alerting notifications. Like the threshold configuration before, we can choose notification severity, email frequency, email notifications on where those should be sent, as well as SNMP trap destinations. For our next topic, we'll look at path and topology. Network path and topology will draw a path between point A and point B using configuration information that has been received from physical data sources. Here we will simply choose two endpoints, a source and destination of our path, select a time range for the path, then select Submit. It's worth noting here that we are not sending any sort of trace packets to draw the path that you're about to see. On our left-hand side widget, we have our layer 3 topology, and our right-hand side, we have our layer 2 topology. Everything that you see on the screen here is clickable for more information. If I go ahead and mouse over the host on the left-hand side, it will give me the host name for that virtual machine. Mousing over the purple square will show information related to the edge transport node, and on the right-hand side, we have the host transport node for NSXT. Now I'll go ahead and click on our source virtual machine to expand information about that machine. Here we can get various information like IP address, default gateway, network address, amongst various other pieces of information. We can do the same thing by clicking on the distributed firewall that sits in front of the virtual machine. This will show any distributed firewall rules that are applied to that specific virtual machine. We can click on the physical host that supports the source virtual machine. This will provide lots of information, including information related to any errors or issues with that specific object. As you can see here, it appears that the host prep vib is unhealthy on this specific host. You are also able to expand configuration information related to the physical objects in the path as well. If you simply mouse over this, it will give you an in interface and an out interface for the path. If you click on that object, it will expand and provide more information such as routing table and routing interfaces for that object. Besides routers or layer 3 switches, you can also add physical firewall devices as well. As you can see here, we have a Palo Alto router device that has a firewall table that's built in. If I scroll down, I can see the firewall rules table, which currently only has a single rule, which is allow for all traffic. In addition to this, you can also click and expand on any sort of NSX overlay devices as well. Here we can take a look at the T0 and T1 services router. Coming over to the right-hand side widget, we can look at the physical devices on the physical underlay. And here we're looking again at the layer 2 information. So this, we're mostly looking at switch ports on the switch ports table, as well as any sort of trunk VLANs or tagged VLANs on those interfaces. Scrolling down on this path topology dashboard, there's additional widgets that we should look at as well. Here we can see the individual path ports that take place between point A to point B. We can look at individual endpoints here. Coming down, I can look at all the events that are related to the objects within the path. The default for this is 7 days, but this widget can be expanded out to a longer duration. Coming further down, we can look at the flow section, which gives us an idea of any sort of communications between our source and destination endpoints of this path. Metrics will show you interface metrics for path ports between the path, as well as metrics related to the path flows. If you'd like, you can change the path port by selecting from the drop-down on the top right-hand side of the widget. For our last feature to review in this overview, I'd like to look at the network intentions as well as the network map. First, let's take a look at the intents. For network intents, you will define a desired state for your network And if that desired state has ever breached, you would receive a notification letting you know that that intention has been breached. We already have many of these currently defined in our demo lab. But let's take a look at what it looks like to define a new intent. Currently, we have three categorizations for network intents: network health, device health, and compliance. To start, you would simply choose the desired intent, assign parameters, and configure. Once configured, you can see the intents that you've created in the main page. Any breached events will be listed on the table that you see here, and the current status will show as well. As you can see here, this reachability intent has been breached and is currently failing. To get more information regarding a specific event, we need to go look at the network map, which will give us better visibility into why the breach has occurred. The network map page is going to show you a network topology of all of the physical devices that you have added to vRealize Network Insight. By clicking on events, we can see any notifications, configuration changes, or alerts for devices showing up in the network map, as well as any triggered intents. If I scroll down to the bottom of this list, we can see that there's a loop detection event that has been triggered. I can click to expand on this event to see more details. Within the detailed list, I can see that there are two paths that have been listed. By clicking on the path icon, it will take me to the path in the network topology, which you can see behind our windows here. It has highlighted both devices in which the loop has occurred. Looking at the path details within the pop-out, I can see the individual interfaces in which the path occurs. We can see that the path starts on device W1CO4, it will pass through the NVDS, and then traffic returns back to the originating device. From here, you should be able to go and make configurations to eliminate any loops within your network. If I would like to look at any specific entities on the network map, if I go to the Entities option, I can click on anything within the dropdown, and it will take me directly to that object within the network map. From here, I can see related objects that are near that specific device. Again, everything on this diagram is clickable for additional information. If you're interested in looking at any individual paths between 2 points of interest, you can simply click on the Paths icon, then enter your source and destination for the path that you would like to see. Here, I would like to see a path between a prod DMZ firewall to a prod data center firewall. The output of this indicates that I have multiple potential paths. Let's look at path 1. If I click on this, like before, it will take me directly to that path on the network map, and on the path details, it will show me each hop between the 2 points that I've indicated. I can zoom further out and reposition the map to get a better look at the hops between point A to point B, as well as other neighboring devices along the topology. With the combination of network intents and network topology, you will now have excellent visibility into your network. This now concludes the topics for this training video. For more information, please see vmware.com or stay tuned for future videos with more detailed feature deep dives.